So what is the base of ln of x? Ln of x is another way of saying a log base e. So the base ln is what's called the natural log. It's a log with a base of e. Rumors often spread equally through a group of people as one person hears something and then tells other people about it, who in turn tell more people. Sociologists studying a group of people determine that the fraction of people in the group P who have heard a rumor after t days can be represented by the equation P equals P0 e to the kt over 1 minus P0 1 time minus e to the kt, where P0 is the fraction of people who have heard the rumor at time t equals 0 and k is a constant. In a particular study, sociologists determined that at time t equals 0, 5% of the people in the group have heard a certain rumor. So that's our P0 equals 0.05. After 2 days, 25% of the people in the group had heard the rumor. How long will it take for 80% to hear the rumor? So what we don't know is we don't know k, and that's important. But we do know that when t equals 2, p equals 0.25. And so we can use that to solve for k. So set this equal to 0.25, and this is 0.05 e to the 2k over 1 minus 0.05 1 minus e to the 2k. And we're going to have to solve this for, we're going to have to get e by itself in order to take a log, take a natural log. So let's go ahead and multiply everything by this. Well, first I'm going to clean up this denominator here. 0.05 e to the 2k. 1 minus 0.05. If I distribute this 0.05, that's plus 0.05 e to the 2k. And I can change that 1 minus 0.05 to be 0.95. So now I can multiply by this denominator, plus 0.05 e to the 2k, and multiply that over here, 0.95 plus 0.05 e to the 2k. And so now I have 0.95 plus 0.05 e to the 2k times 0.25 equals 0.05 e to the 2k. Going to need to distribute this. It's not going to be pretty. Sorry about that. But 0.95 times 0.25 is 0.2375, and 0.05 times 0.25 is 0.0125 e to the 2k, and that is equal to 0.05 e to the 2k. We're going to subtract this, 0.0125 e to the 2k. So that ends up being 0.05 minus 0.01, so 0.05 minus 0.0125 is 0.0375. 0.0375 e to the 2k. And we can then divide by 0.0375 on both sides. And so that is 0.2375 divided by 0.0375. And that is going to give me, ends up giving me 6.33 equals e to the 2k. Now, when we put this in log form, right, we're going to take the natural log, and so this is log base e, which is the natural log of 6.33, equals 2k, and then we're just going to divide that by 2. So k equals ln of 6.33 over 2, which is, let's make sure we put that 2, that divide by 2 needs to be outside the log. And ends up with a k of 0.923. So if our k is 0.923, now we can plug that in and solve for the time t when our p is equal to 0.8. So, right, we get a k that is 0.923, and we want our p to be 0.80, and our p0 is still 0.05. And so, delete this so that now I have room. And so now this is 0.8 equals 0.05 e to the 0.923t over 1 minus 0.05 e to the 1 minus e to the 0.923t. And I'm going to do that same simplification here where I distribute this 0.05 and make this 0.923t and make this 0.95 minus plus 0.05, because the minus and the minus, plus 0.05 e to the 0.923t. And we're going to multiply both sides by that denominator, 0.95 plus 0.05 e to the 0.923t. And do that over here, 0.95 plus 0.05 e to the 0.923t. And so 0.95 times 0.8 is 0.76 plus 0.4 e to the 0.923t equals 0.5 e to the 0.923t. If we subtract that 0.4e from both sides, we're going to get that 0.76 equals 0.01 e to the 0.923t divided by 0.01, which is going to end up being 76 equals e to the 0.923t. And now we can take our log. So we put this in log form. We're going to get ln, natural log, of 76 equals 0.923t divided by 0.923. And we're going to get ln of 76 divided by 0.923 ends up being 4.69. So our t is equal to 4.69 days. Convert log 6 of 254 to a natural logarithm and evaluate. So in order to do this, we need to use our change of base formula. So that would be ln of 254 over ln of 6. And if you do that, ln of 6, and that ends up being 3.1. Uh, 6.5 equals negative 16.25 ln of x. So go ahead and divide by that 16.25. You can take the negative with it. So 6.5 over negative 16.25 is equal to negative 0.4 equals ln x. And then we can rewrite that in exponent form. That's going to be e to the negative 0.4 power equals x. And e to the negative 0.4 power is, my calculator doesn't like doing that. E to the negative 0.4 power is 0.67. We can use natural logs to solve equations as well. So 3 to the 2x equals 7 to the x minus 1. If we take the natural log of both sides, equals ln of 7 to the x minus 1, then we can move the 2x out front and move the x plus 1 out front. So we have 2x ln 3 equals x plus 1 ln 7. And so we're going to need to distribute this ln 7 here to both the x and the 1. So this is going to be x ln 7 plus ln 7. Now we need to get all of our x terms over to one side, so we're going to subtract x ln 7 from both sides. And so this is 2x ln 3 minus x ln 7 equals ln 7. Now we can factor out the x's, and this is 2 ln 3 minus ln 7 equals ln 7. And then divide by all this non-x stuff. X equals ln 7 over 2 ln 3 minus ln 7. And if we do that on our calculator, that's going to be ln 7 divided by 2 ln 3 minus ln 7. And that ends up being 7.74-ish. We can do the same thing with part B. We just are going to treat this less than as an equal to. It works basically the same way. So if we do natural log of 6x squared minus 2, natural log of 48, bring this x squared minus 2 out front. We're going to need to distribute the ln 6. So this is x squared ln 6 minus 2 ln 6. This is still ln 48. Go ahead and add the 2 ln 6 to both sides. So x squared ln 6 ln 48 plus ln 6 plus 2 ln 6 there. Divide by ln 6. So x squared is less than ln 48 plus 2 ln 6 over ln 6, which is ln 48 plus 2 ln 6 over ln 6. So that gives us x squared is less than 4.16. And if we do the square root of that, that ends up being 2.04. So if x squared is less than 4.16, we end up with either x is less than 2.04, but also greater than negative 2.04. Because we could also get a negative 2.04 squared would also be 4.16. So negative 2.04 less than x less than positive 2.04. And that would be the answer. So it works the same way as solving the equality. It's just that at the very end, when we get the x squared, we have to put it as an interval because we could get both a positive and a negative. And this will work. You don't have to use ln. You could use any log base. You could use the regular log base 10. For this one, you could use log base 6, and that would work. For this one, maybe log base 7. no matter what log base you use, you should still get the same answer. So maybe for fun, try doing it in a different base and see if you get the same answer. And that's it for natural logs. Hope you learned a lot in this chapter, our last chapter of the school year. And get ready for a quiz coming up soon.